All right, thanks everyone for coming back. So right now it's time to start the discussion panel. So we've gotten all of our morning speakers here, right here with us. So here's how it's going to work. We have a couple of questions prepared for all of you guys. But again, if anyone in the audience is interested in asking a question, we'll break for audience questions after one or two of ours. Sound good? Cool. Okay, so let's kind of start off with a more applications-oriented question. So a lot of you guys are working on autonomous driving or whatever particular application, but I'm kind of curious, what would you guys say is like a primary goal or a set of primary goals for safe autonomy in the context of your application areas of interest? So yeah.
Yeah, I'll start. So I'm kind of working in the human-centric AI division. So it's about kind of understanding and putting kind of structure around how humans behave. So it's more about the representation power of, I would say, the formal methods, techniques that we've been that kind of float around so far and are being kind of worked on, and bringing to bear kind of these things on how do you test the system when you know that because if you're a generative model of a human, it's often difficult to kind of use that to kind of verify whether or not the system's working. So the idea and the dream is really to can we come up with a representation that's both accurate to the human, but also kind of you can feed to a verifier and say, okay, verify this. So part didn't come through in the talk because it was part of the kind of the motivation for why we're doing that, but kind of gives you the gist. So yeah,
sure.
That's one perspective.
Quickly, safety, of course, is a very multifaceted topic, very difficult to define. So it's difficult to give a monolithic answer to your question. For example, in the field of autonomous driving, there is a differentiation between functional safety, safety of intended functionality, with a lot of different branches beneath. But one interesting aspect, since you mentioned autonomous driving, is that, of course, an autonomous car is a system that is operating, interacting with humans. And so we always think about safety being the primary responsibility of the system under control, but in reality, the notion of safety also entails some notion of shared responsibility with other agents on the road. So I think yet another dimension is to what extent that safety somehow should be negotiated with other agents on the road, and to what extent we can rely on others to be safe and helping us to be safe. So if we really didn't provide you an answer, but I made the topic even more complicated.
Right.
So I guess my interest step all the way back to even start understanding what safe even means, right? So at the high level, you might think of it as, oh, we just need to ensure no collision between the two objects. But that's not really just the case, right? You need to also care about the perceived safety. And it's not even clear what that means. You want the person to sit in the car to feel that they are safe. You don't want to, a person to sit in the car praying for all the whole ride and then come out and then we say, oh, see, you are alive.
So
right? Yeah. So I think we need to first get a good understanding of what that even means for the system to be safe. How do we make people feel safer? And it might even be different for autonomous system versus human driven system, right? People have less trust maybe in autonomy. So the definition might be even different. And we need to first understand what does safe even mean in that case.
Hi. So actually, Nook and I work for the same company recently. So my interest is in basically what Nook showed. So which was rule books, right? So they, while at Autonomy, they started looking into formalizing traffic laws, right? So is there any way you can actually look at traffic rules, like the big book that every state has, and is there any way you can actually formalize them, write them into, like, for example, in STL, or some sort of Boolean logic with well-defined syntax and semantics, and then have a large collection of those. And then when you deploy your vehicle, is there any way you can actually satisfy them somehow? Obviously, they need to be prioritized. It's more important to give have clearance to pedestrians versus not exceeding the speed limit. So is there any way we can do that automatically? Right. So rulebooks, what Nock showed is, I think it was the first shot at that, and for the past couple of years, I was looking into how to map that into control problems. So you guys don't know, we can discuss more.
So I'll be short and reiterate what I told in my talk. So it's agnostic of applications, provable guarantees. I think that's what I would focus on and encourage the community to work on. We really need to make progress, whether it's autonomy, the ML components, but it's just getting extremely complicated, and we need to work on how to ensure safety of individual components, but also a holistic autonomous vehicle or whatever application we're working on.
Cool. So thanks for all the answers. So it seems like we've identified several kind of open problems here. So I guess one question is, would you guys think that kind of a lot of these open questions that like applications of autonomous driving have brought up, do you think that academic research is kind of well aligned with these notions? If it's not, how can we maybe focus on more, I don't know, how can we maybe adjust our focuses? And to maybe more of Pavithra, how can funding agencies potentially drive this in the right direction?
So yeah, I cannot give all the details, but we do get feedback from the community, right? And that's extremely important to us. Firstly, we encourage you to submit proposals, excellent proposals in areas related to provable guarantees and autonomous systems and all of this. And we at NSF also, we are aware of the challenges. We are seeking additional opportunities and programs that we could develop so that we can encourage more research in specific areas that we think are critical. So it's extremely important that we get feedback from all of you guys on and help us steer the programs that we are developing.
I don't have.
So I think one thing I want to add is that so a lot of talk about definition of safety, traffic rules. I think it started to get beyond the boundary of science, right? Get into philosophy, regulations, and it's probably we would need help from those stakeholders as well. I think from the science point of view, what we can try to do is that we come up with some flexible formulation that we can formulate what safe, reliable really means, and some approach like what Calin is doing to implement or to develop the system based on the formulation. But I think a big problem right now is getting back to what does it really mean for the system to be safe.
So, yeah, I think Calin is well positioned in many topics, but there is one fundamental weakness, at least when it comes to vision about safety for autonomous driving, which is typically the lack of data. I mean, in many cases, the safety concepts need to be data-driven, of course, for verification and validation, but in many cases, even for design. First, before I was mentioning the notion of responsibility. Responsibility, by its very definition, is something that has to be at least learned to some extent from data. So it's commendable that some companies are sharing some data sets. And I think as a community, we should try to get even more data sets in the hand of the academics, otherwise our research will one hand tied.
Yeah, I'll double down on that too. I mean, I think the data is really like the fundamental challenge, and it's kind of the oil that needs to kind of be infused in some of to vet the techniques that we have. That's super important. But I also point out too that I guess the original question was about sort of like how can we make sure that academia and industry kind of sync together. So I'll just say that like the conversation, I mean, I'm coming from TRI, And
Right.
we don't always know what we want, but the conversation needs to happen between academia and industry. So I'll just point that out, that it's very useful to just sort of have that back and forth. And, you have, if you're developing this tool this way, we can kind of like figure out like, are there, what are the gaps, what are, like, really think critically about like, how it is that we actually need to implement this in our systems. Like if like, data is the limitation, fine, let's kind of solve that problem. If like other things like runtime or complexity are an issue, let's tackle that. So not every, there's no silver bullet for everything, every problem out there, but yeah, I think that's what we try to do.
Sure, sure. Maybe where you going?
Well, I just really wanted to say that on the positive note, at least in the United States, academia is actually quite free in terms of allowing faculty to collaborate with companies. For example, in NVIDIA, now Calin has been working with Motion now. Of course, John is at TRI. So at least it's something that really facilitates the gap, for example, in terms of data, filling the gap, for example, in terms of data.
And yes, we really encourage people to collaborate with the industries. They not only constitute the broader impact, but they're essential in the kind of problems we're looking at today. Especially there are specific programs that allow collaborations with industries like GOLI that you might want to check out. Though NSF will not directly fund the industry part of the research, the the collaborative aspect is highly encouraged.
I guess just as like a high-level follow-up, so we're all kind of emphasizing the cooperation between, academia, industry, and kind of government funding agencies. Do you think the level of cooperation is kind of sufficient right now? Is there anything that we can kind of do to generate a better platform for all of us to kind of communicate with each other?
I don't know, I think it's-
That's for all of you guys.
What do you guys think? Do you think there was more collaboration required with industry?
Well, I think it would be great to have a bit more, and there's the NRI and the CPS, like its larger programs of NSF definitely encouraged. I mean, they even brought industry into the funding process to actually fund specific projects. So yeah, that would be great. I mean, imagine as faculty, if you can actually just go to NSF and then NSF puts you in connection with like an industry partner. And like the GOLI program, that's very nice, right? Because industry, they usually have their own research funds, but the NSF would just fund the academic part. So yeah, but again, I guess, I don't know, so but does NSF have any plans to make this a bit more, I don't want to put you on the spot, but I mean, and I think NSF did a great job recently, and I just mentioned the NRI and CPS, but is there any more incentive on like bringing industries, especially like this big robotics and autonomous driving company that so much money can actually fund something through NSF or in partnership with NSF?
I'll skip that question.
Okay. But again, I think this is what we desired. I guess
Yes,
that's
but
what
I understand.
Okay. We should also take questions from the audience.
Yeah. Any questions from the audience? Please go to the microphone.
I can do the walking.
Oh, well, there's a microphone.
Oh, there is a microphone.
That's it, yeah.
That's this heavy job as well.
Yeah.
Yes, so I want to ask a more kind of narrower question. So imagine we're talking about this autonomy in an unexpected, unknown environment with some distribution shift, like driving at night or seeing that stop sign on the billboard. And imagine we want to output some safety information, some safety metric, and we want a couple of things from it. We want it to be interpretable by the human sitting in the car. We want to be able to act on it with some guarantees. For example, we want to pull over and know that we're not going to have a false negative there or rate of false negatives. And we want to have, so we want to have guarantees on how well we know the safety metric or the safety information. And I heard a number of them, potential such metrics, like entropy, risk, some satisfaction function for the assumptions, let's see, probabilities, of course. So I want to hear some opinions of what could this metric be? What's the ultimate, runtime safety with provable guarantee kind of metric that we want to put out there?
my mask up. So I can, for example, share my experience a little bit of the, so that's one of the things that you mentioned, the satisfaction of traffic laws that are stated as formulas in certain logics, right? So there's metrics to quantify that satisfaction, there's the robustness that Jonathan mentioned. But then the predicates that you have in those formulas, like distance to pedestrian, you know, the measurements for that are noisy. And then there is the classification problem. Are you really seeing a pedestrian? So there's so many levels at which, you know, they have to be taken into account when you, before you even talk about robustness or satisfaction of that formula. So I think I don't think we have the right theory. Maybe you guys can argue on that, but we don't have the right theory of dealing with this semantic classification, noise in terms of measurement of quantities, and then the actual spec and the degree of satisfaction of that spec. I think that's an interesting research question.
First of all, as part of the design, people use a safety KPIs, for example, for perceptions in terms of false positives, or dynamically informed false positives, for planning in terms of time to collision, and so on and so forth. So there is, from a functional safety standpoint, not saying that the problem is solved, but that there are well understood way of a function decomposing your stack, attaching different safety KPIs and so on. From the safety of the intended functionality standpoint, I'm really skeptical we can really provide proof due to the very open-ended nature of the problem. So it's really going to be a never-ending quest in combining safety assurances that come from the functional decomposition with data-driven evaluation and testing perhaps in a simulation. I think that if our goal is to provide a proof, I think we might be set for failure.
I guess I can add a little bit to that. I think right now you might start to hear about it in terms of providing the proof. One concept that industry started heading towards too is the operational design domain. So instead of having to operate in completely open, unknown environments, people try to scope down. This is the kind of environments that we know how to handle, and then develop another system on top of that that detect when the car goes out of the ODD situation. And I think that might be one way to provide some form of guarantees in this setting.
But one of the things I would say assurances in the sense it wouldn't be approved, but it's not something new. For example, when you design a controller for an aircraft, you use techniques from linear feedback control systems to make sure that your phase margin is a desirable one, but you don't really have proof that the aircraft is not going to fall out of the sky. So it's not something new to engineering. It's always going to be a combination of make sure you have a good design using techniques of proven methods and so on, but then using them data-driven methodologies, both as part of the design, but then for the testing and validation.
So on to the next question.
Hi, you talk about leading data sets. I'm actually publishing the small data set right now, be larger later on at this workshop. But it's focused on anomaly detection and it's made for general robotics. But you were asking for data sets for autonomous driving, safety on autonomous driving. What kind of data do you want? Like, what kind of samples or information should be there?
Yeah, sure. For example, one key, another several data sets provided by autonomous driving companies from Waymo, from Lyft, from several of them. But for example, if you want to do research on the topic of interaction aware decision making, these data sets typically fall short because they do not really allow to capture the interactive aspects of behavioral planning. Motional actually is come out with a new data set called New Plan that tries to bridge this gap of reasoning about closed loop interactions as opposed to open loop interactions, but it's still in early phases, and the data available to do that type of research, so behavioral planning, rational decision making is extremely minimal. So in academia, what you are left with is basically some relying on some models that are questionable in terms of how representative are in terms of modeling other humans, which in turn make it questionable whether the results that are achieved and published in the papers really translates to actual results in the field.
Sorry, question. It seems to me then what you are kind of asking now, General Manager, a kind of data set that only large companies or entities should provide. Because if that kind of information is what you require, then no more research institute or university could provide that information.
That's right.
Okay. Yeah.
I like the fact that we're conversing about data-driven safety or safety guarantees, because I think in general common methods we have always been focused on model-based approach, and it is important to go towards or incorporate the fact that they're getting more and more data. What do you think will happen 10 years from now? What would be a good guarantee to seek when we try to bring data to this? Because my understanding at this point at least is whatever approaches that are trying to incorporate data seem to still have a flavor of model. You're assuming, I think earlier Mark was talking about having a Bayesian prior, and those hyperparameters that you have in your prior would be affecting your output distribution in the data. So that to me still is kind of corrupted by whatever model that you would impose, and the safety guarantees would be subject to what was assumed. So do you guys have any idea on what you think would be a gold standard which both industry and academia should seek for in sort of giving safety guarantees when you have data?
Yeah, that's a hard question. Who wants to take that?
Yeah, I'll try to add some color to that. I mean, I guess to Knox's point of having an ODD, you might have some, similar kind of support for the data, and to which your system has been sort of trained on or validated on. So you have your validation set, your training set, both kind of contribute to kind of like validating or verifying to some extent, even like at these very just for the data set, the system is verified. But the question is how to move away from that. We don't really have a great answer. I mean, there's a lot of ideas floating around, but yeah, that's just it's an outstanding problem. Yeah, but it's a good question.
Well, I mean, quickly, more on the design side, I think what the community is going towards, I don't know what will happen 10 years from now, but at least in the next few years, is basically using formal methods as a sort of inductive biases for your data-driven components. For example, the work of John is a great example, right? So you're using STL as a sort of an architecture within which then building your learning models. You can have many other ways of doing so. You can bring to the table techniques from reachability and more. And I don't think, again, this is going to lead us to a guarantee or a proof. I'm really skeptical about this notion, but at least to a better design.
Yeah, so to add a little bit to that, so I think at least for autonomous driving, you will never have a system that is like 100% no collision, right? Because you have to deal with other agents, human drivers, person who might want to commit suicide by jumping right in front of the car. But the question is, we can still use model to get an understanding of what kind of assumptions that we can put in, and in those situations, we know that the system will behave correctly. You can think of that as like in aerospace, for example, right? The system is typically very safe, but still it's not 100%, right? So there are still cases where there's a crash, but you want to at least be able to bound what the percentage that would be. Would that be safer than if human were to drive themselves or not?
Yeah, mine is gonna be a bit more narrow. Like I'm thinking, kind of supporting what Marco and Jonathan said. Maybe try to go towards unifying models learned from data, models that we use. Like again, a good example would be you do what's called temporologic inference. You look at data, come up with a formula that describes, what you saw in the data. And then maybe the model of a vehicle shouldn't be like x equal to f of x, but should just be another formula. because we always think of formula as being specifications, but they can be models too. They have time, right, which is kind of a dynamical system, but they have richer things such as Boolean operators, and so try to maybe unify them somehow, and then obviously once you try to prove satisfaction, it's never going to be like false or true. It's always going to be some sort of a quantitative measure or some probability. And statistical model checking, it's been around for a while now. We can have large systems and you just simulate them in the right ways, and you have a probability of satisfaction, and that statement also has a confidence interval of like two probabilities on top of each other.
So I would like to open up a different aspect to this. We all think of formal methods as providing guarantees on system, but formal methods can be a great tool to also aid in testing and finding bugs, right? So if you're just doing an exhaustive testing, there are lots of bugs which are almost impossible to find, but using formal methods can give you a very good tool to direct your search towards finding those kinds of bugs. So falsification techniques are one example of those kinds of tools. So I mean, this also leads to increased confidence in the system. So, and it's a good direction to put efforts in.
Okay, let's take one last question.
I was wondering, what are each of you guys' current goals for research considered to be done or safe? So like, at what point do you consider your research complete and saying that this is safe from what you're trying to pursue? Is it so many percentage of out of deviation data points, or is it so many rules? And is it so many guarantees? And kind of, what are your current targets you're chasing for research?
You talk about autonomous driving still, or in general?
If your research on autonomous driving, the speeds of autonomous driving.
Thought about the answer, yes.
So I don't think you can stop and say, yeah, yes, the system is safe. Because one, as Mark was saying, it's an extremely challenging problem and you are never going to get absolute guarantees. As Mark said, we need to make assumptions and so on. But also, these autonomous systems are not static themselves, right? They are improving and becoming more and more complex, and more challenges that are coming in every day. So I would say that it's a bit hard to stop and say, yeah, we have safely verified something. It's about striving for getting this greater confidence in the system.
With that said, when you want to ship a product, at some point you have to attach some metrics, right? And of course, for different components, there are such metrics which are a function of the probability that something goes wrong, whether you can control the situation if something goes wrong, and to what extent you have exposure to that type of failure mode. Of course, I can't disclose the numbers, but one number that I think is fairly accepted in the community is in the case of ghost brakes, which is one of the annoying things with autonomous cars. So if you have a car with advanced autopilot, probably you have experienced some brakes without any apparent reason. It should be, as a rule of thumb, about 1 of 10,000 hours. And there are some reasons about where that number comes from, but yes, in many cases it's arbitrary. But at some point you have to put thresholds, otherwise you wouldn't ship a product.
So I'll just also mention that, yeah, this is a huge problem. Like Pavithra said, it's like highly interdependent. Like, so if things are changing in the autonomy stack, then you have to verify like everything over again. So what it really boils down to is a set of tools that so far the view is like, internally, if we could use some tools in falsification to kind of like understand how to better come up with scenarios to test your autonomous car and understand how it's safe, that's a very powerful kind of tool, because then you can obviously do that testing much more efficiently. you would otherwise do. Yeah, there's other things like, just code, even formal methods for programming, that's also very, to detect, and to kind of like assert bugs that you could be introducing inadvertently while you're coding is another kind of like lower level thing that we haven't really talked about, but it's so important.
So I think to add to the point about testing, I think it would be nice to get to the point where the formal method of application, we could get to the point where we could understand statistically how often the system is going to fail, even before we put the product on the road. Right? So right now, a lot of it depends on you actually put the car on the road, drive for a few million miles, and then look at how many accidents happen. But I think we could do better. We could try to even get better understanding before we put the product on the road, right? And then try to estimate how million miles, how many times the crash is going to happen. And if we change the design, how is that number going to reduce or increases? I think that would be sort of the ultimate goal.
Yeah, absolutely. That's the holy grail, and that's why one of the holy grails in this field is represented by simulation. And in particular, in the case of autonomous driving, there are three main aspects. There is the aspect of photorealism to stimulate the sensors, which I think we're pretty good at it right now. There is the aspect of a physics modeling, but for vehicles, unless you're driving in very difficult situations, is a relative step forward. And this is the aspect of behavioral modeling simulation, which I think we still have quite a bit to go before we have data-driven agents that are really the mini-set of all the nuanced behaviors that a human could enact. But yeah, absolutely, that's the holy grail in a way in this field.
Okay, great. Well, I would like to give a round of applause to all our speakers for a fantastic discussion.